Hello and welcome to Sharda e-learning educational video tutorials. We are now starting our course for mathematics and statistics for standard 11. And in this video, we will study some introductory part of angle and its measurement chapter from part 1. So angle and its measurement. So what is meant by angle? What is meant by angle? We know angle is a combination of two rays. Suppose OA is a one ray and OB is a another ray. Then the rotation formed by these rays is called as angle, and we can measure it in a degrees or in a radian. So we know how to draw different types of angles and how to measure. We also know there are angles related to the circle such as central angle. We have studied all these concepts in previous standards. Now we will study some more concepts. So let's start by doing it. The first one is directed angles. What is it? Directed. Directed angles means angles which have direction. Angles which have directions. As we consider here, one ray OA and rotate it till it takes the position, another position. I will rotate this ray OA. I will rotate this ray OA to the new position OB, right? Then angle obtained so is called directed angle, right? So, and how it is called? It is called as AOB. It's called as AOB, angle AOB. So, what will be the definition of this directed angle? The definition will be the ordered pair of rays. Listen carefully. The ordered pair means the pair should be in a order. The ordered pair of rays OA and OB together with the rotation of ray OA. Rotation of ray OA. These are the ordered pair. This is the ordered pair of rays, right? Together with the rotation of OA to the position of the ray OB is called a directed angle AOB. Directed angle AOB. If the rotation of initial ray is anticlockwise, the measurement of directed ray is considered as positive. If the rotation is anticlockwise, we know how clock and anticlockwise rotations are. We can define it by using our clock direction. Clock goes this direction, right? So it is called as clockwise, and opposite to this is a anti-clockwise. Okay, so these are the direction we know, rotations. In our angle, when our initial ray, suppose this is the initial ray OA, is rotated anticlockwise. Anticlockwise means this direction, anticlockwise. Then it should be positive, right? And if our ray is rotated clockwise, right, then it is called negative. Amount can be same, but they should be in positive in this case because it is initial arm. What we said in the definition is it should be ordered pair. It should be ordered pair. The first OA is a initial arm and OB is a terminal arm. Similarly here, OA is a initial arm and OB is a terminal arm. So both these angles are called as angle AOB. Get it? Both these angles are AOB, but this one is positive and this one is negative. Why this one is negative? Because OA is rotated as a clockwise and here OA is rotated as anti-clockwise. So these are the angle formation of directed angles. So what we got here is various notations like terminal angle, initial angle. We will reconsider these definitions again. Suppose we have angle like AOB and it has ordered pair of OA, OB. These are the rays in ordered. So it should be called as this one should be initial, right? Initial ray, and this one should be terminal. This is initial ray and this one is terminal ray. So we can call it as angle AOB. And the second example, if same, but in this case, suppose ordered pair is OB, OA. Here it was OA and OB. Here it now be OB is written first. So order has been changed. Order has been changed here. Here initial ray is OB and OA is a terminal ray. We know what is mean by initial means starting, right, and terminal means stop. So initial ray is OB, which is written first, right? In ordered pair, it order is so important. That's why it's called as ordered pair. Pair means two, and ordered means in order. OB is the initial ray. As we when we write OB first, it gets first initial, and OA is terminal. So angle will be BOA. Angle will be BOA. Even if the measurement of angle is same, suppose it has a 30-degree and it also has a 30-degree, but we cannot call these two angles same. It is not equal to each other, right? Because they have a different ordered pair. Got it? So this was a how angle forms is just rotating the initial arm to the terminal arm. Initial arm is rotated till the terminal arm, and it is written as in ordered pair, right? So we will see now different types of angles now. The first one is a zero angle. First one is a zero angle. These angle definitions are important. They will be we will be using these angles in uh, later chapters. So what they mean is very important. Zero angle, but it's quite easy actually. It suggests its name as a zero, means it should have a zero rotation. If the ray OA, which is our row ray OA, has a zero rotation, means it is not moved. So initial arm is also terminal arm. Terminal arm is also initial arm. Initial arm is also terminal arm. So the angle formed is zero angle. Zero rotation. Rotations does not happen here. That's why we called it as a zero angle. Okay. Then one rotation angle. One rotation angle. So at its name suggests, there should be one rotation, complete rotation. OA is our first ray, right? And OB, where should be OB ray? It should be after one complete rotation. Complete rotation means we should complete this full rotation, right? And again, it should be on the same line. When we complete full rotation, it will go on the same line, right? So measurement of this angle was how to write angle. First, write measurement of this angle. Angle AOB. AO is the initial ray and OB is the terminal ray. What is the amount here? Zero means zero. Zero angle means zero measurement, right? Zero rotation. Similarly, here one rotation angle. Here is also same name of angle, which is angle AOB, right? And it has a value 360 because it completes the full rotation. Okay, when it's a one rotation, we know it should be angle 360. Okay, next angle is a straight angle. Next angle is a straight angle. Straight angle. After the rotation, if the initial ray OA and the terminal ray OB are in opposite directions, then directed angle is called as straight angle. After the rotation, if the initial ray OA, initial ray, as always, we have initial ray OA, okay, OA, and we are going to rotate it. But after the rotation, what happens? What happens? The terminal ray is in opposite direction. If ray OA is in this direction, what will be the opposite direction? The opposite direction will be this. If terminal ray is in a opposite direction, this one is a initial ray, right? And this one is a terminal. So this one is called as a straight angle. This one is called as a straight angle. Okay. Note that in this case AOB is a straight line also, right? AOB is a straight line and also called as a straight angle. And half of one rotation angle is a straight angle, right? Half of a one rotation angle. What was the one rotation angle? One rotation angle was complete the circle, right? Completing the circle. But in this case, we are doing it only half. So it is a half of one rotation angle. So measurement of what is the name? AOB. It should be 180 degree. Straight angle is a 180 degree. So these are quite simple to understand. Now we have next angle, which is a right angle. We know already what is meant by right angle, which has a 90-degree value, but now we will consider it in our directed angle. 1/4 of one rotation angle. 1/4 of one rotation angle. 1/4 of one rotation. 1/4 of one rotation is a right angle. So 1/4 of one rotation is right angle, means 4 into right angles is equal to one rotation, right? 4 into right angle will be one rotation, right? How to draw the right angle? The OA, which is our initial ray, right? You can go either here, which will be the positive, right? And this will be the negative, B or B dash. So measurement of angle AOB is also 90 degree, and measurement of angle AOB is also minus 90 degree. Minus, because it is a clockwise, right? Four right angles, these two right angles and this one makes the whole rotation. Okay, the right angle was easy. So this was some concepts of angles. Now we have this concept called angles in standard position. We have a standard format for each thing in mathematics, whether it is a linear equation or it is a quadratic equation. We have always a standard format so that we can represent it on some scale. So in a rectangular coordinate system, a directed angle with its vertex at O. Okay, if we missed the point, what is vertex of the cone AOB? What is a vertex? So O is a vertex. Always remember, O is called as vertex, right? So angles in standard position. Angles in standard position. So how to represent the angle in standard position? In a rectangular coordinate system, a directed angle with its vertex at origin O and the initial ray along the positive x-axis is called a angle in standard position. Means we know the rectangular coordinate system. We draw graph on our graph paper and then we use this x-axis, y-axis, right? And this one is a O, which is the origin. Now what makes the standardization of angles is when the initial ray is on the positive x-axis. Is it initial ray is on positive x-axis, right? So suppose there is point OA. OA is a positive x-axis, and you can draw angles at different points, right? Suppose this one is P, Q, R. Yes. So this one is a first angle, right? Because OA is a, what is OA? Is initial ray. Initial ray, and OP is a terminal ray. So what is the angle here? Angle AOP. Now, if we use this one is as a terminal angle, we used OP as a first terminal angle. Now we use OQ as second terminal angle. Then what it becomes? It becomes angle AOQ, right? I have shown the angle here. This one is second angle. Now if the R is our terminal angle and OA is the initial angle, always remember whatever the terminal rays, the initial ray should be on positive x-axis in our standard position. That's why it's called as a standard position. When OA is the initial ray which is on positive x-axis, right? Positive x-axis, and O is as origin of our angle. Sorry, origin of our coordinate system, and also vertex of our angle. Okay, that's why. But you can change these terminal angles where you want. So this one is a OR is a terminal angle. So what is the angle now? Angle AOR. So this one is a third angle. This one is a third angle AOR, and this one is yes OS. So this one is our fourth angle AOF. Okay. So these are the standard positions of our angles in coordinate system. Okay, so we can see here there are angles in different quadrants. We have already studied what is this quadrant called as quadrant 1, right? This one is a quadrant 2, this one is a quadrant 3, and this one is a 4, right? We already know this. This one is a quadrant first, this one is second, this one is third, this one is fourth. So angles in quadrant, basically what it is, so identifying the which quadrants they consist of. So angle here, angle XOP is in a first quadrant, angle XOQ is in a second quadrant, angle XOR or AOR, you can call it A or X, we are right both here, you can use X or A. So angle AOP is in first, AOQ in second, AOR in third, and AOS in fourth quadrant. So these are the angles in quadrant. So next one is a quadrantal angles. Quadrantal angles. A directed angle in a standard position whose terminal rays lies along x-axis or y-axis. We know in standard position initial ray is always on x-axis, is always on positive x-axis. But when terminal rays, we didn't know about terminal rays before, right? Terminal rays could be lie in any of the quadrant, but in some cases if terminal rays lies on x-axis or y-axis, terminal ray lies on x-axis means this one or this one or this one, right? They are called as quadrantal angles, right? So what are the quadrantal angles here? XOA. XOA is a quadrantal angle, right? XOY is a quadrantal angle. XO, suppose here is B. XOB is a quadrantal angle. Quadrilateral angle means where the terminal ray should be on the x-axis or y-axis. Okay, understand? Then the coterminal angles. What are the coterminal angles? Let's study what is meant by coterminal angle. Coterminal means the directed angles of different amount of rotations having the same position of initial rays and terminal rays are called coterminal angles. Again, I will read the sentence. Directed angles, which are we have been studying here, of different amount of rotation. How many rotation does not matter, but they have the same position of initial rays and final rays. So, if OA is our initial ray, then the zero rotation means zero angle, what, right? Zero angle OB. It is the suppose OA is the initial, OB is the terminal. Then angle AOB, right? Then suppose we have a angle here AOB, right? So angle AOB has some rotation here, right? So this one is a terminal angle. But what we said is initial rays and terminal rays should be same positions, right? They should be have a same position. Does not matter how many rotations will be there. Directed angles having, suppose this one has a 30 degree. If we have a rotation again, then it should be adding 360. So it is a 390. Suppose we have one more rotation, then it should be plus 360, right? So these all are called as terminal angles. Terminal angles are the different amount of rotations. Terminal angles have different amount of rotations. Maybe they have a anti-clockwise, sorry, clockwise direction. Maybe they have a clockwise direction. So when it has a clockwise direction, what it is? It's a minus 330 degree. So 30 degree minus 330 degree plus 390 degree. So these all are called as coterminal angles because these all angles are have basically the same terminal and initial rays, but it has some different values because of their rotations, right? Because of their rotations, the 30 degree in positive direction goes 30 degree, right? The 30 and in the negative means in the clockwise, it gives the value 330, and if we rotate one more time it gets 390. So these are the angles which have same initial arm ray OA, same terminal arm OB, but these have different rotations, and so this called as coterminal angles. If the two directed angles are coterminal angles, then difference between their measures are of the two directed angles is an integral multiple of 360, right? Because rotations are only in multiple of 360. So we can see here 390 minus 330 is also 720, right? Which is a 2 into 360. It should be always in a multiple of 360. 30 minus 330, which is also 360. So it should be in a multiple of 360 degree. So we understand what are the coterminal angles. Coterminal angles are having the same having the same OA, so initial and terminal rays, but amount of having different rotations. Sometimes it's anti-clockwise, sometimes it's clockwise, sometimes it's one rotation, sometimes it's two rotations. But in the end, it should have the same initial and terminal rays. So we have studied what is meant by directed angles, how they created. We know our directed angle is a combination of two ordered pair of rays. Ordered pair means there should be order in it. The first one is called as initial, the second one is called as terminal. When initial ray is rotated to the terminal ray, then the directed angle is called as angle is called as directed angle. We know what is meant by initial ray and terminal ray. Then we defined the different types of angles: zero angle, one rotation angle, straight angle, right angle, and then angles in standard position, right? So in this video we have studied these types of angle. Now next video will be on the measurement of angles and how the measurement system of angles works. Then we will see you in our next video. Till then, thank you very much.